Всем добрый день. Меня зовут Сергей.
Hello, boys and girls. Name is Sergey Sobolev. I do work for Positive Technologies, auditing ton smart contracts and other smart contracts. In fact, we shall start by reviewing what the ton blockchain is, what's made of, how smart contracts work there, and after that, we will discuss general code vulns as well as specific ton vulnerabilities.
Итак, блокчейн Тон. Его называют блокчейн блокчейнов.
So, Ton blockchain is actually called the blockchain of blockchains. The most important thing to remember is that it supports the so-called actor model, meaning that all accounts are effectively contracts, and these contracts are called actors. They've got their own features such as balance and state. And naturally, such messages need to be validated. This is where you can find a host of problems because you can have replay attacks there, for example. So if a SIG is not unique, it can be replayed many times. The TTL of a transaction also needs to be taken into account. And the way you receive a message is also important. There are so many ways you can attack a message. With replay, obviously, but you can also do a DOS, wherein you grab a contract, and, for example, you make mistakes in it. So you see we are accepting messages here, we've got some data stored, and then we check if it's unique or not, we're checking the SIG, and then we accept the message. Now imagine that an invalid message gets sent, then during the next loading, and this an example below, we open a cell, we enter data there, twice 32 bits every time. So we upload the first 32 bits, we check that it's a unique nonce or a secno. Next we check a signature, something that I'm not showing in my example here. And then we have cell read happening, or rather there is a link to a cell, but we fail to indicate it. This is where execution stops, and the current transaction nonce will not be stored, meaning that the validator is going to try sending this message until it runs out of gas inside the contract. Now let's look at the replay attack. Using, say, one-time numbers. So this one actually comes from a contract wallet. Now imagine you've created a wallet, the first transaction. We'll have this wallet up and running, and then you will be talking to the wallet. So you see that the PKI here, a public key, has been stored here, and we are checking the number of transactions using the sequential number. Next one is smart contract update. On TON, it is done in a simple way. You are simply changing the C3 registry. You can also do the set code. The set code is not going to impact current code execution. So when the compute stage happens, set code is set, and in the next stage, an action is performed to update the smart contract. You can actually bypass it by using set3. Set C3, by sending a new code to the smart contract for it to be executed, as long as the addresses and names of functions are consistent. So what I'm showing here is an excerpt from a real project.
Вот. Какие у нас нюансы с обновлением контрактов? Это опять же...
What are the nuances related to contract update? One is data collision. So if we screw up in contract updating, there could be issues in storing data or reading data from storage. So, since it's FunC, we are simply storing a single cell that needs to be created manually. There are lots of decentralization issues, like who is going to update the contract? What if they do it consciously, purposefully, in a malicious way? Randomness generation. Now, there is a set of functions you can use. It is recommended that you use randomize LT. So it adds logical time randomness to a transaction.
Использовать такое псевдослучайное число, но это подходит.
So this way you can use a pseudo-random number, which should be okay for small projects or tests. On Tact, you've got more options. There are some native functions, which are in fact inherited from FunC. And there are some internal Tact functions, which are more secure than what you can come up with on your own. So you can randomize a transaction. For example, you grab the logical time of a given message, and obviously all messages will differ in terms of the logical time. So you can no longer repeat the same transaction
выиграть лотерею, допустим.
in order to win a raffle, for example.
Достаточно сложно сделать, но в принципе можно. Есть
I mean, it's not entirely impossible. So I'm thinking of a particular CTF
обсуждается задача того,
where there was a task
перебор,
in FunC, in fact,
отправляйте, и в какой-то момент
to sort of, brute force it all.
разницу между сообщениями.
So effectively, you can brute force the right LT.
Ну, тоже там зависит от некоторых вариантов.
They're not taken sequentially, they're taken like with a delta of 2, but it can be done.
Мы можем
So
сделать
remember, we have master chain and work chain.
лотереи в workchain.
So we can have, say, a raffle contract in a work chain. Then we invoke randomness and we go to master chain. We take randomness there, and then we return this randomness to the work chain.
Практически невозможно.
That will be very difficult to predict, right? I mean, it's not impossible, but very difficult.
Случайность
And then you can send this randomness several blocks later.
на это все могла повлиять. Ну и плюс
So you will need a group of validators to be able to manipulate that.
самый такой децентрализованный.
Next one is the most decentralized and the most secure way of doing it, where you commit a random number.
Мы сами придумаем и отправляем, получается, в контракт хэш. Это как раз таки есть коммит.
And you send the hash of it as a commit in the contract. And everybody else does it in a daisy chain.
Опять же, есть
And then they kind of disclose their randomness.
последний человек, который
Now, the problem, however, is that the last person to disclose it can actually impact the ultimate result, although you can protect against that as well.
контракт проверяешь, либо пишешь. Вот. Почему валидаторы могут предсказать значение?
Why can validators predict a value? Is sort of obvious, right? Every block has a seed,
Функция рандома и
and the random function actually draws on the seed.
в принципе, сейчас я вам рассказал такой порядок.
I've given you so far
Надо делать при мануальном аудите.
the list of things you will want to do when you're doing manual audit of your smart contracts.
Посмотреть.
So you should draw the flowchart of all messages, check for usual code vulnerabilities, also check for specific blockchain vulns and specific tone vulnerabilities.
Характерные уязвимости для языков как раз-таки можно.
Also, there are some characteristic vulnerabilities for specific languages. High-level languages are easier to read by humans, meaning that it's more difficult to make mistakes there. Contrast it with FunC, which is a low-level language,
Больше знаний для.
meaning that it actually requires more acumen
Тут можно пообщаться. У меня
among the programmers. This is how you can get in touch.
на GitHub я выложил
So you see my Telegram on the left. On the left, I'm sorry.
чек-лист.
Middle code takes you to my checklist on smart contract audit on GitHub, and do participate in our CTF where we've got ton contracts and EVM contracts. So you go to positive.com to participate in the CTF. This is it for my presentation, unless you have any questions.
Надеюсь, какие-нибудь есть.
Да, коллеги,
Anything?
находятся по бокам.
Yeah, we've got mics on both sides.
Я так понятно О, давай.
Вот микрофончик там. А вот на стоечке. Да, вот.
Привет, спасибо за доклад.
Hello, thank you for the presentation. Lots of goodies, but I failed to understand many things.
Газа не хватит газа. Это
You kept saying you can run out of gas.
или баланс кошелька?
Ну, по сути,
Are we talking about wallet balance or compute power here?
понятие газ.
Well, it's more like wallet balance. So on blockchain, we have this notion of gas. Gas is how much you are going to pay for any transaction that will be executed, and you pay in tokens.
Деньги там
So when you send a transaction, you spend your own money. This is usually several dollars, but it can be several $100s. Is that what you failed to get?
Ну, в плане подробно.
Yeah, it's just that I don't really know much about blockchains. Thank you very much.
Есть лимиты на транзакцию.
Alex, there are also transaction limits.
В тоне там плюс-минус это 0,4 тонн.
On ton, it's like 0.4 ton,
Примерно такие цифры.
which is roughly 1 million gas.
Превышать это, все будет падать, и, к
So
сожалению,
if you manage to exceed that,
в случае
Гипотетически,
you run the risk of losing your transaction.
грубо говоря,
So hypothetically, if you forget to replenish your balance, you will be able to lose a transaction? Yes,
там же есть
absolutely.
еще понятие того, что, к примеру, когда мы отправляем внешнее сообщение, обрабатывает
So when you send an external message,
внутреннее сообщение, там можно пересылать газ.
it's the receiver that handles it. In an internal message,
Дальше
you can send gas, spend it, send it again.
газ, который у нас есть на
So
контракте.
it can easily happen that you have sent all the current gas inside a contract, and then you send two messages. So one message will be sent and the other one will not, because you won't have enough gas for it.
понял, спасибо.
Things like this do happen. Understood? Thank you.
Есть еще микрофон поближе. Вот там.
Mic over there.
Да, спасибо за доклад. Собственно, у нас
Thanks for the presentation.
база разных проектов, в том числе
Now we've got a large code base for various projects, including DeFi, mostly on Ether, not so much on Ton, for the obvious reasons, because Ton is younger, but there could be other reasons as well.
сложности архитектуры на тоне
In terms of architecture complexity, are Ton projects more bulky? And do they require like better talent for
Мы
development?
переходим из категории, вот мы пишем там внешние сообщения у нас же есть, если вот от них отказаться,
Remember what I told you previously about external messages. If you disregard external messages,
контракты на Solidity, сообщения,
you end up in the world which is very much like Solidity. You send messages by calling functions.
синхронные, и как раз-таки вот это
The only difference is that they are asynchronous. So this asynchronicity does create more issues.
программирование
Like you gotta know something about parallel programming.
желательно.
So this is computer
В
science.
принципе,
I'm tempted to say fundamental
проблема
computer science.
в том, что
Now, you asked about bulkiness. It's a matter of the language itself, tact language.
все типы данных, storage никак ты там
Just like Solidity covers all sorts of data, types.
структурами, и дальше
You're only dealing with structures, and under the hood, it will create the right kind of structures for you in the right cells.
более громоздкий
Now, with FunC, this is where it will be bulky, to borrow your word.
Ну вот что здесь понятно? Здесь ничего.
Now tell me if you can read much here.
Что каждый флаг
I don't think you can read a lot. I mean, you gotta check all the flags first.
Но если мы там в коде, то тут очень много вот как раз-таки таких проблем, что
So there are lots of issues like this.
читаемый.
The syntax is not very readable.
Пожалуйста.
Thank you. You're welcome.
Я вообще ждал вопроса про реэнтранси.
I actually have been expecting questions about reentrancy.
Нет, там невозможен.
Повтор.
And reentrancy is not possible.
Повторный этот... Реплай так можно, реэнтранси...
Replay attack is possible, but you cannot do reentrancy.
Как она делается? У нас есть...
Remember how you do reentrancy.
Входим, делаем
You
внешний...
have a contract, you enter it,
Возвращается...
you make an external call, and then the external call does a callback to the initial contract. Since we have asynchronous execution,
Завершено. Соответственно, баланс...
there is no possibility for reentrancy. The balances will be updated by the time the callback arrives.
Актуальные данные, но это уже...
I think you can find a workaround,
Race condition.
but that will be not so much reentrancy, but rather a race condition exploitation. And it will be pretty difficult to exploit that.
Нехватка газа,
Is it possible
долгих,
that you run out of gas
например, электр, номинатор и
when you have a lecture, nominator,
отваливается.
and at some stage, it sort of drops. So,
Ну, тут
in other words, can you please elaborate on partial transaction execution? You have to calculate how much gas will be spent and how it will be split between messages. Because you cannot simply transfer all the gas.
Про частичное исполнение.
Remember my answer to the first question.
Отправляем несколько сообщений, и если мы между
We send several messages.
правильно газ,
If we fail to distribute gas between them,
за счет того, что нам нечем будет его
you
заплатить.
know, a message can be dropped simply because we won't have money to pay for it.
Потоки. И потребность газа стала больше. Надо
So can it happen that the need for gas increases while I'm performing a transaction? Or you mean the cost of opcode will go up? I'll say you've updated the code, and then the amount of gas you're sending is no longer sufficient.
Продолжать, но я думаю, надо
I think you can screw up like that.
смотрится, пересматривается.
So if you're updating your code, you absolutely need to check how much gas it's consuming now.
Ну, вполне себе такое может быть, да. Ну, то есть,
So yes, I think it's a possibility.
ну, короче, может быть, да.
Интересно. Ладно, спасибо большое.
Interesting. Thank you very much.
Полчаса, да?
See you in 25 minutes for the plenary discussion, where we'll be talking about cryptography and AI. Thank you.